I have heard many times about how people want to replace all of tier one incident response with AI powered tooling. And that is exactly the worst possible place to put AI tooling. Tier one is where you have the lowest concentration of expertise and the highest cost of mistake.
Have you ever wondered if our entire understanding of this technology, from how we secure it to how we use it, is built on misconceptions? Welcome to Behind the Binary. In this episode, we get a reality check from mathematician and security expert Kevin Harris. We'll dismantle the industry's preconceived notions, from the real definition of prompt injection to the dangerous fallacy of replacing humans with code, and why we haven't actually invented artificial intelligence yet. And now, my conversation with Kevin Harris. One of the areas that is getting a lot of attention, social media and in news and otherwise, is this idea of prompt injection. What are your thoughts? Prompt injection, indirect injection, I think jailbreaking you mentioned as well.
Yeah.
What are all these things that we're wrestling with right now?
So prompt injection is probably the most overloaded term in AI security right now. When people say prompt injection, they actually mean a lot of different things. The two big categories that falls into is what is actually prompt injection, and then a thing called jailbreaking that we can talk about a little bit in a second. But really what a prompt injection is when you think about interacting with an LLM, there are a set of instructions that you pass off to that LLM before the user gets to put their prompt in. And then the user says whatever they're going to say. They type the thing that you want to put into the chat box, and those things get concatenated together and then sent off to the model. Now, that instruction set is not intended to be data. It is intended to be instructions. The user prompt is intended to be data, not instructions. And a prompt injection is confusing the model about what is instructions and what is data, right? Because from the model's perspective, it just got a block of text. All it's doing is trying to continue a conversation. Now, some of those portions of those conversations might start with a tag that says like system : and then things. And then some of it might say user : and some things. And what a prompt injection is just like a SQL injection, where you inject a piece of text that looks like an instruction, that confuses the model to think that it's an instruction. And when you think about it in terms of like input validation, the problem is similar for prompt injection specifically. But I think one of the things that's often confused when you think about LLMs and LLM-based applications is prompt injection feels like you're attacking the model, but that's not actually the case. In the same way that a SQL injection is not attacking MySQL, it's attacking a web application that uses MySQL as a backend. A prompt injection is attacking an LLM-based application that uses an LLM as a backend. The model is just doing what the model does. From the model's perspective, there is no difference between instruction and data. It's all data, right? So when one tries to make that differentiation, that has to happen at the application layer. That's where that problem lives. And it's difficult. There's a few different methods that people have come up with to try and fix that problem, but it is a difficult problem. However, when we talk about jailbreaking, this is actually a thing that most people call prompt injection. Jailbreaking is where you trick the model into thinking that the rules don't matter, right? It doesn't matter. It's not a question of like getting it to look at your prompt and think that it is instruction sets. You're just trying to get it to pretend to be something that the rules don't make a difference. You can think of it like gaslighting. You're gaslighting the model into going into some context space that that's useful to you for whatever your ends might be. I think the prime example that I like to use to demonstrate jailbreaking is to tell an LLM to become a pirate, right? Now, the reason that that's useful is it tends to be funny enough that nobody has input filters to stop you from doing it. It's a cute way to show off what you can do with an LLM because it'll speak with a jaunty accent or whatever. But the thing that's important to recognize is that pirate means a lot of different things. Pirate isn't just this, jaunty Jack Sparrow caricature. It is also 3 or 4 different kinds of criminal, right? And so when you tell the model to take on the role of a pirate, you can build this context window where eventually you can ask it to break the rules, and it will be happy to do that because it's a
Mhm.
pirate and pirates break the rules, right?
Yeah, yeah,
That's a jailbreak. It's where you set a context window for the model to live inside of that the patterns it has learned for behavior refusal don't apply anymore. That is a much harder problem to solve than prompt
yeah,
injection, because prompt injection, as you suggested, is like it's about input validation. You're not attacking the model, you're attacking the application. And it's a harder problem to solve than SQL injection because you have to think about intent, and there's a million different ways that you can say something that looks like it's an instruction. But jailbreaking, I mean, I don't know that there are good answers to how to deal with jailbreaking yet. I don't even know that there ever will be, because that flexibility, that ability to change context, is what makes LLMs valuable, right?
yeah.
So
Right.
if we dial that back, like, what are we left with?
It's interesting because you, there's just so many different ways in which you find, and like maybe not nefarious ways. I run across this with models. Let's say I'm trying to develop a little bit of code for a training or a class or some educational purpose, like truly educational purposes, and I go to a model and it's like, oh, I can't help you with that. That looks like it could be malware. But then I provide it with a little bit of code and it's like, oh, I'd love to help you with that. And then it starts and finishes off all of the work for me. And the complexity of trying to determine that behavior and that intent behind the user and whether they're injecting or jailbreaking, it just seems so, as you just said, it's so incredibly hard. I'm not sure at what point do you see these behavioral guidelines, these the paths that they have to learn in order to prevent such a thing? Like, where does that typically get baked into the system? I mean, imagine that if that's part of the model, then it's on the organization to pick the models with the proper safeguards that they want to utilize, or are they left with figuring out that themselves? Because I don't usually see the safeguards in the model until I start interacting with it, and then it becomes apparent where it's going to tell me yes and no, and how clever I want to try to get to bypass it.
Well, it's actually, so in my experience anyway, it's all of the above. The safeguards are in every place that you can put them because none of them are particularly effective, right? Like one of the one of the biggest, I guess one of the quietest truths of AI security is that all of the defenses that exist to prevent things that are attacks against actual LLMs, not the web applications that they live in, but the actual like LLM itself, that against a skilled adversaries have a 100% success rate against all of the defenses that we know about, right? In every case, if you put it in front of a red teamer and give them enough time, they will figure out a way around it that is 100% successful. That's not like, sometimes it's always successful. That's problematic, right? But most of the defenses are 60 or 70% effective against unskilled attackers, which means that if you put just one up, all you're doing is slowing people down for a couple of days until they figure out how to get past it. But if you put many up, then it becomes an expensive endeavor to figure out how to get past your particular system. And so the only people who will do that are people who are determined adversaries who are looking at you as a specific target, which means you can shave off the bulk of the people who are out there on the internet just trying to spam whatever kind of an attack they can get to stick to the wall. So in most cases, it's going to be a little bit of everything. A lot of folks who are paying for access to the big models. Important note about how LLMs operate. Very rarely does anybody have more than one model. Usually you have one big one, and then you reach out to that one model over and over and over again because they are incredibly expensive to host as inference endpoints. They take a ton of compute. So most of the time, the big models that exist are the ones that all of the applications have backing, and the relationship that any one company might have with one of these big model providers is going to depend heavily on the contract that they negotiated. Some of the big model providers will require that only authenticated users can interact with the API or can send text. Some won't. Some will have their own logging and filters in place. Some won't. It's a question of the front end company, what they've negotiated. But in my experience, it behooves everyone involved in this to put as much security as they can afford to put around it. And the traditional stuff exists. Put authorization. That's a really great way to slow down some of the attacks, because if somebody has to create an account, sign into the account, give a credit card that's valid to get access to the account,
Right.
even if you're not charging them, like that just takes so many people out of the pool that a lot of the abuse cases that we've seen, at least a lot of the abuse cases that I see, just immediately get scraped off. And then you put input filters in place. You put stuff that's like, in one particular domain, we expect to see a lot of these kinds of statements and not a lot of these kinds of statements. So we're going to create a filter that prefers the things that we actually know are good use cases, and the stuff that we don't expect, we're more happy to filter out. And that's always going to be bespoke for any individual use case, as opposed to at the big model level. But when you look at like jailbreaking, because so much of that is about context, a lot of that gets, the better ways to deal with that are in the context of the model itself. Let's take a step back, actually. When we're talking about prompt injection and jailbreaking specifically, but a couple of the other key types of problems that LLM-based applications have, there are three big categories of defensive measures that we have thought about in the last few years. The first is input based methods. So that's your you give the sandwich method is a great example. I'm going to give a set of instructions, and I'm going to take your prompt and I'm going to put it in after the set of instructions, and then I'm going to remind the model of the rules afterwards. Right? That's the sandwich method. So I'm just going to inject your data into that. So it's always getting a good example. That's an input defense method. Now, the next big one is a detection. That's where most of the filters are in place. That doesn't have anything to do with the model at all. That's about, I'm going to look at the thing that you've entered. I'm going to run it through some set of detection algorithms. Sometimes it's other LLMs. Sometimes it's classical ML. Sometimes it's much more simplistic than that. But then I'm going to flag things as being problematic or not. And if they're not problematic, then I'm going to send it off to the LLM. That's the kind of stuff that a lot of folks who are implementing connections to large models, that's where most of their defenses live, is in that detection space.
Yeah, I was going to say that, like, for a traditional security team, that seems like the place where they might fit in the easiest, because they can put in. I mean, my mind goes to IDS. It kind of seems and feels a little bit like an IDS thing, an intrusion detection system. Like, okay, here we can force this to go through some predefined rules, or some, like you mentioned, some ML or something, and try to catch the things that are bad. We've seen how that's played out over the years, but it does seem like the least point of friction for a team to be able to have some sway in the process.
Yeah, well, and like many cases, the folks who have the best data about what bad and what normal looks like are the people who are on the front line. So if you have like a detection and response team, if you have a company that has a detection and response team, the stuff that the logs they're pulling in, that's the gold mine for what normal looks like. And really, most of the time when somebody's trying to do a jailbreak, they are acting in a way that is really abnormal. There's actually a really great specific kind of detection that can be very useful. It's a perplexity filter. So perplexity in the context of an LLM is how surprised it is that some set of words were used, right? So when an LLM goes to generate text, it will generate the whole conversation. We actually have to tell it to stop. Like you'll have this system and it'll say stuff, and then it's agent. The agent will say stuff, and then user. And when that user tag shows up, you have to tell it to stop generating text because they don't know things, they don't think, they don't understand, they just say, right? So if you let them go, they will keep going. Well, you can actually use that to your benefit because when it gets to that user tag, you can let it go and have it show what it thinks the user is going to say, and then compare that against what the user actually says. And the deflection between those things, that's perplexity. That's how surprised the model is by what was said. Typically, particularly in the context of like jailbreaks tend to have a very high perplexity because the context shifted in a way that the model didn't expect. Whereas normal user interactions have a low perplexity. Now, just because something has a high perplexity doesn't mean that it's necessarily going to be malicious, but it is something that you can, if you're at like a DNR level, in a particular company where you can build perplexity models that are really fine-tuned for your customer base and understand like what normal looks like, and if something is unusual, at least flag it to like go through other filtration. Another benefit that security teams have in that filtration space is that most of these models have really, really high latency. Right. So when I go and send a request out to a big model and it has some thinking it has to do, we're talking 15, 20 seconds of thought at minimum for many of the kinds of questions that people care about. That's a long time in the context of detection. Right. So you got all of this extra time to figure out whether or not you actually want to continue the conversation. So if you're capturing good logs, if you're going through those logs and finding bad guys and then figuring out what bad looks like versus what normal looks like, you can build some really good filters. And that I think you're right. That's where the traditional security teams can engage in a light way. And then the third one is model-based. Model-based, you have to be training your model. Like you have to be responsible for training the model. Not a lot of people are self-hosting LLMs. They're incredibly expensive, and the pace at which they are improving is such that like it doesn't make a lot of sense for me to stand up my own model and then just have it suck 2 weeks from now by comparison to all the rest of the models that are out there. Right. So when we look at the model-based solutions, those all live with the companies who are building these big services, and they are doing better and better jobs, but it's hard to know. So like the example that you pulled up, where you go to generate some code, you ask it to generate code, and it's like, no, that looks like malware. But then you start working with it as a developer, and then it just happily continues the work that you're doing. The reason that happens that way is because when models have this concept of attention, they look at different parts of a conversation to draw into a search space, right? They functionally memorize the entire internet. All of the text that is available on the internet is available to this thing. But when you start to use very specific lexical structures, right? When you use fancy like jargony terms, only certain portions of the internet use those terms. So it very quickly draws its attention to just that space where those terms are used in the way that you're using it. A really good example is my wife is a forensics teacher. She teaches a bunch of science classes, but forensics is one of them. And I helped her to generate some forensic analysis reports. That's not the kind of thing that you want to go and grab real ones and then use those in class, right? So we went to go and generate some of them, and I had no idea. I don't know anything about like medical forensics. I don't know anything about that. But I went and found some actual reports, found a series of jargony keywords, and then asked the LLM to generate text with these specific headers types. Like, I need a section for this, and I didn't even know what they were. But the thing that it spit out when I put it in front of my wife, she was like, "These look incredibly real." And it's because the only place on the internet that used those terms were ones where people were actually dealing with these real reports, right? So when you ask it to generate something that looks like malware, you look like a low-skilled cyber attacker. Right. And so it is trained to say, no, this is not a thing that I should engage in. But when you start providing it with code and very specific, like terminology that makes you look like a software engineer, then the context is very different. The easy way to say this is that, like, if you ask a question that looks like a question you might find on Reddit, you will get a Bodie McBoatface answer, right?
Okay.
But if you ask a question that looks like something that you would find on a PhD forum, then you get an answer that looks like a PhD response, right? The models are not designed to report on truth. They're not optimized for validness or for political correctness. They're optimized for plausibility. So whatever the most plausible response is, that's the thing that it's going to give you. And I guess another way to say this is that, so one of the hot takes I have on AI in general is that it doesn't exist. There is no AI. We have not invented AI yet. The intelligence that's involved in these systems is not artificial. It's yours, right? The LLM is not demonstrating intelligence. It's reflecting your own back at you, right? And so the words that you use, when you ask a question as a subject matter expert, you get back responses that look like a granulated, aliased subject matter expert response. If you ask questions that look like a novice, you get back lies, right? It reflects your own intelligence back at you. It's not artificial.
I feel kind of weird using the word AI, but it's kind of like cyber. I think I've just settled on it because it's easier than saying LLMs and models and all the other sciencey stuff that goes into it. But you see it like manifest itself in really interesting ways. I have written a number of training submissions for conferences. I've noticed a lot of times, especially when I say, hey, I want to write a proposal for Black Hat and I want it to be grounded in the syllabus, but also be engaging. It comes up with all sorts of over the top language. And I suspect that part of that is because it's tying into that marketing world within the model itself. And it's like, okay, this is how people talk like this.
Yep.
It constantly surprises me at how its inherent desire to please and to provide answers. And even when it's going off on the wrong track, with how the models are developed, you could be going down a path, doing some research, for example, but it could be 90% wrong at this point because it's trying to provide it does have a really hard time of saying, I don't know, or I have no further information, or that's it has no concept of truth, as you just mentioned. It's just
well, like I said, the models are optimized for plausibility, not truth, right? And the most plausible if you have read the entire internet, the most plausible continuation of any conversation is never I don't know. People don't say that a lot, right? Not on the internet. And so the way that I always think about LLMs is it's like a really enthusiastic intern that will never tell you I don't know. It will never say no, and it never gets bored or tired, but it's always a little bit drunk, right? Like if you can think of a way to use that intern that I've just described to make your processes better or faster, then you've probably found a way that LLMs will make your life better or faster, right? Mm-hmm. But if you have a problem that requires expertise, that requires like understanding, and that intern will make that process worse, then you probably shouldn't use an LLM for it. Right? Because they can't say I don't know. It's not actually possible for them to do that. This is actually one of the biggest like ethical risks that exists inside the AI space that not a lot of people talk about. There's this concept of AI induced psychosis, where people go to an LLM with something with a belief that is implicitly incorrect, that's driven by some kind of underlying like mental illness or something along those lines. And then when they show up with a context, a whole world that is not reflective of reality. But LLMs don't have the ability to understand reality. They don't understand. They don't think. They don't know. They just say. And they reflect back the world that you give them. So if you show up with a fundamentally flawed world and then ask questions to like, well, I'm trying to understand, or I'm trying to see whether or not it's always going to just reflect that world back to you. And so there's a whole bunch of people who have found these models and are using them as research tools, but really what they're doing is exacerbating a disconnection from reality. And it's terrible. Like, it's a terrible thing that exists in the world, and it's hard to deal with. But I think that the thing that you suggest is the right path forward for that. It's that we have to teach people how to use the tool. It's just like a table saw. A table saw is an incredibly useful tool if you use it for what it's designed for. If you don't use it for what it's designed for, it is an incredibly dangerous machine, right?
Right.
And LLMs are the same. They are incredibly powerful tools in the hands of experts, in the hands of people who both know how to use them and who can tell the difference between real and false when it gives answers, right? There was a meme I saw going around that said the promise of AI was that it would democratize knowledge, but what it actually did was give experts jetpacks and beginners very convincing blindfolds. And I totally agree with that. Like you, I use it all the time. I mean, that's my core day job. I have to, but I use it all the time to solve problems. And the reason that it's valuable for me is that when I ask it a question, I ask it about something that I already have domain expertise in. So when it says something stupid or crazy, I can see that it was stupid or crazy immediately and just discard it. It costs me very little when it's wrong, right? But when it's right, when it tells me about like a pandas method that I didn't know existed, and then suddenly saves me a bunch of time because it shows me how to use that thing. When it's right, it is incredibly valuable to me. Those are the circumstances where LLMs are actually really powerful, where when it's wrong, it costs very little or nothing, and when it's right, it's incredibly useful. But if you reverse that, if I put that in the hands of an intern or a junior engineer who isn't going to know when it's telling it, when the things that come back are false, and then they follow those paths and end up with a bunch of broken stuff or things that don't work in the ways that they expected, or research that is just like factually incorrect, that's incredibly expensive for them. It hallucinating, which is another term I don't like, because they're not hallucinating, they're lying. But when it gives one of those little lies, that's really expensive for somebody who doesn't have domain expertise, because they end up having to expend a bunch of energy to figure out that it's wrong at all. So it's an inversion of how the model should be used.
I think that's another area that I've observed with non-technical friends and colleagues, that they're oh yeah, I'm using it. I had a conversation the other day. Someone was using it to generate SQL queries for business reporting, and I said, "Well, do you know SQL?" No. I was like, "Well, exactly what we're talking about. It really is. It's most effective when you understand and you can correct it, because if you can't, then you never know when it's misleading you." And I've had experience recently too, where I've been back in the world of writing a lot of SQL queries, and I've been able to use it to generate and use SQL methods I didn't even know existed. But I have enough insight to look at the query that's generated, spot check the things I don't understand, do a little bit of reading, and say, okay, this makes sense. I think this is accurate, and I'm using this the way that I intended to use it to get the results that I'm after. Yeah, it's crazy. I mean, I think that kind of ties in a little bit too to the hype that we had with this cycle. Of course, this has been big. It's profound. It's a very different technology than we've ever had. It's interactive in a way that I don't think the average consumer. I mean, I remember years ago hearing about how machine learning was going to change the security landscape, and nothing ever really concrete that I experienced proved that to be so, but there wasn't as much hype around it. I mean, there was some, there was a lot of ML based security products for a period of time, but this one's different. Where do you see the hype that we've been living under, and like the future? You mentioned AI, it isn't here. And, it seems like it's all related and connected. So,
yeah, well, I mean, so I think all technology goes through a hype cycle. That's just inevitable. And like you said, this one seems to be much bigger than most. And I think that the reason that it is so big is because Kubernetes, when that came out, there was a huge hype cycle. Everything needed to be a microservice for 4 years, right? Yeah. But Kubernetes couldn't convince a VP that it was important on its own, right? Whereas like an LLM can do that. It can actually tell somebody why it is an important thing. But it just has a much more public face. It's a technology that non-technical folks, just regular folks out in the world, can interact with and can do so to great effect. So that added a lot more publicity to it. And along with publicity comes investment money, right? And so as soon as that investment money shows up, then there's a whole bunch of promises about what it could be. Sadly, the tech space over the last like 15 years has become a lot about drawing investment on a future that they believed was possible to get to, and then just doing everything they can to get to that before the money runs out. The problem with this one is that LLMs look like intelligent systems. They feel like they understand and know. It feels like it was a huge step function closer to the concept of general intelligence, of what actual artificial intelligence would be. But in reality, it's not that big of a step function. It is a step function. It is a real step function, but it's not a huge one. All we have done is make predictive text better. That's it. Like 3 orders of magnitude better, a lot better, but it is still just like predictive text. So I think a lot of the dreams that people had about how this was going to completely change the economy required it to be good in ways that was never going to be good. So a really good example of this is robotics, right? When robotics came into the mainstream, like it was available in mainstream manufacturing, there was visions of fully robotic, like all of the systems. It was going to be robots that delivered parts, and the robots were going to move the parts around the warehouse, and then the parts were going to show up on assembly lines, and everything was going to be robots, right? And that's simply not what happened. There were some robots. There are some robots. There are a bunch of robots that exist inside of these manufacturing pipelines. But like when I go to McDonald's, I'm not served by robots. And the reason is because it's actually really hard to flip a burger for a robot. It's something that's really easy for a human being to do, but it's really, really hard to get that like kind of manual dexterity. Grabbing just 2 pickles and putting them on a burger is really difficult to make a robot do. But teaching a person to do that takes 30 seconds, right? And so I think when we look at a lot of the problems people were hoping to solve with this, they were problems that were of that scale, where it looked like an easy problem. So of course, this very powerful technology is going to be able to solve it. But in reality, for that technology, it's incredibly hard. So a good example, I have heard many times about how people want to replace all of tier 1 incident response with AI powered tooling. And that is exactly the worst possible place to put AI tooling, because of that, the thing that we were just talking about as far as expertise. Tier 1 is where you have the lowest concentration of expertise and the highest cost of mistake, right? So if you put AI powered tools in that place where they're likely to make mistakes often, those mistakes become very expensive very quickly. It slows the process down. But if instead you think about not automating things, but augmenting capabilities, you leave tier 1 alone, and then you take that augmentation and put it on your tier 3, then they become much more effective at solving hard problems, and you get a realized value of it, but it's just not the huge realized value that everybody thought it was going to be. So I expect that we are very close to the end of this step function, right? So I'm a mathematician at my core, right? My undergraduate degrees in theoretical mathematics. I work in AI now. Like math is my life. Whenever we enter any kind of an exponential growth curve, business people want it to be a singularity, right? They want there to be this asymptotic line, and it's going to climb up this exponential growth curve forever. But that's not how nature works. That's not how anything in the universe actually works. When you go throughout all of the places in the universe where you can mathematically model things, and you see that exponential growth curve, it is always on a sigmoid curve, not an exponential growth curve. A sigmoid curve is one that goes up and then comes down and flattens out. It always talks It always describes a state change, ice melting, a star just before it goes supernova. All of these things are on this state change curve. And so I believe that this technology is on that exact same curve. You see that the first company that comes in and comes up with something good has this explosive growth and shoots out in front of everybody else. And then everybody else who enters that curve is going to be behind them. If we were on a real exponential growth curve, then they would continue to get further away faster, right? The further, the more advanced they got, the faster they would leave everybody behind. But in very recent times, the biggest LLM provider in the world had to call a code red. And the reason they called that code red was because their competitors were closing the gap in quality. So if the first people to enter that curve, the ones who got on that explosive growth, if people are catching up, that means that we've hit the top of that inflection point. That means that from my perspective, I would say that the models are going to keep getting better, but they're not going to get a lot better very fast, that we've started to slow down. I would expect, as a guess, as like a wild guess about like the future, never try and predict the future. But I would guess that we're one or two material science advancements away from seeing another major step function change. If somebody figures out a way to like 10x the compute available with the same amount of electricity, we'll see another step function increase. But right now, I think we're getting to about what physics will hold. So the best models that are out there are probably about as good as they're going to get. The best applications that we've seen of use cases for these things, we're probably not going to see many that are like substantively better than that. So I think a lot of stuff, I think a lot of the promises that have been put forward about how this was going to change the world are going to fall really flat really fast, because they were banking on this continuing on to the concept of general intelligence. And I just don't think that's going to happen. I don't think it's going to happen in the short term. Maybe it'll happen in our lifetime, but I don't think that it's going to happen in the next 5 or 10 years.
I mean, I don't follow the space incredibly closely, but enough that I hear people talking about AGI and ASI, and it's coming quicker and sooner than we think. And I mean, even just in my own experience, I've endeavored this year to try to understand more the science behind the LLMs and how they work. And the more that I got into it, the more the limitations just became a lot more obvious, and I don't know, just sort of that superficial layer of intelligence that it's portraying to you because it's conversational that just isn't there. And so it's helpful. And I mean, I think you're spot on with the educational and just being very careful with who's using it and how, because it's weird. You're seeing a lot of that tier one, I guess maybe across the board, like developer, the company X is now using it to generate a bunch of code. And I would imagine, if I had to guess, that a lot of that code is going to be some of the more mundane entry-level style code. You're building out classes and frameworks and templating things. And okay, we can automate that out. I don't know what kind of bugs and errors and security vulnerabilities are being introduced into it. I don't know how reliably it can do that with consistency. But now we're also eliminating this class of worker that isn't going to grow in experience. And so now there's going to be this growing potential gap between those new people to the field and someone who now has that experience to be able to use it as an augmentation, as we were talking about. And that could be, I mean, I don't know how it's going to play out, but that could be another really interesting area. I got in front of a class the other day, and one of the students was on their way to studying computer science, wanting to get into programming. And they're like, well, where do I need, what are my entry-level skills do I need to start? And I'm like, well, I think at this point you need to know how to leverage LLMs to your advantage, and raises the bar, but in a good way. You still need to learn all the fundamentals though.
Yeah.
You still need to be able to call out when it's wrong. So like the path you're on isn't bad. You still need all that fundamental knowledge. Just add in your ability to leverage the LLMs and you're probably in a pretty good spot.
Yeah, I agree. I mean, you got to learn. So one of the reasons I find myself like, I feel like I've won the lottery 2 or 3 times just by having been interested in things before anybody else was interested in them, and then those things turning into to big things in the world. When I first started playing with LLMs, it was when the GPT-2 model had first come out, and GPT-2, you can actually still go and pull it down from GitHub. It was open source back in the day, and it's a really great way to see how far we've come. That I think is also one of the ways that I indicate that we don't have a lot more to go, because GPT-2 to GPT-3, huge step. GPT-4 to GPT-5, there's a step. But one of the things that I have gained in playing with those models, those older models, and just being around them a lot, is I learned how to not trust them. Right? Like they have a voice. The models have a voice, and there is, when you get a sense for what that voice is, you also get a sense for when it's pulling from things that are more factually based versus things where it's making it up on its own. Like a really great example of this is if you ask ChatGPT specifically a question and it responds really quickly, you shouldn't trust that. If it's a creative question, if it's an ideation question, cool. But if it's like a question about the world and it just snaps out an answer, just because it came out quickly means you shouldn't trust it. It didn't do any backup on it. It didn't have any thought process. It didn't do any web lookups to like verify what it was thinking about. It just responded based on the weights it had available to it. And that is very likely going to be wrong, particularly if it has to deal with facts. And that's a thing that you pick up just by spending a lot of time with them. Those like intuitions about when the model is more or less trustworthy. And that's a skill that you can't teach people. It's just something that they have to build up.
Well, I think there's a lot we could talk about. I have a strong suspicion that you will be one of the hopefully one of the many return guests to continue this. There is one other area you'd mentioned again before we got recording here. Talking about MCPs, and there's a number of things that even in that brief conversation that was kind of surprising to me. One is that the protocol itself isn't that old. I thought it went back a little further than that. And
last November.
Yeah. Okay. So that's crazy. It's only about a year old. The other thing you said was just how that it has some incredible fundamental flaws. And so I was hoping that maybe we could talk here as we probably round out the podcast, of this session, just talk a little bit about that. Like, what do you mean by what are the flaws? What do you think the impact is? I mean, that seems to be the way that a lot of interaction is being developed for, between client applications and these models.
So MCP in and of itself is really just a new wrapper for the concept of an API. That's really what it is, right? We've gone through a bunch, right? There's SOAP and REST and GraphQL and all of these different ways where we have resources and we have applications and we want to make those resources available to the applications. That's all MCP is. All it is doing is making those resources available to an LLM so that the LLM can interact with them in a way that's useful, right? But as soon as LLMs get an opportunity to make decisions, that's and push buttons, right? When they can use tools, that's where things can go off the rails. And this is from a definition perspective, where I would go from talking about LLMs to start talking about agents. For me, an agent is an LLM-powered application that has the ability to do tasks. It can take in text and then it can do things. It can send requests. It can write files. It can change permissions, right? As soon as it can do a thing, it becomes an agent, and it becomes something that is worth concern. Because the core fundamental flaw is that LLMs are very easily tricked. The thing that we just talked about, or I guess we talked about at the very beginning, this concept of jailbreaking, it is very easy to create a context in which the LLM makes bad decisions that we don't want it to make. It's when we think about systems as like technical professionals, we often think about authorization, right? We think about like, what is this allowed to do? But we very rarely think about discretion. Does this thing know when it shouldn't do a thing, right? We reserve discretion for human beings because they have minds. We can talk to them about things. We can put them through trainings and say, here's the circumstance where you should do this thing. Here's a circumstance where you shouldn't do this thing. And we trust you to have the intelligence necessary to figure out that hazy gray area between those things. That's where discretion lives. Systems don't have that, but models require it. That's the fundamental flaw of the MCP, of MCP as a protocol, is that we are implicitly giving agents discretion where they have access to a number of tools, and we're providing them permissions that are reflective of ours. I give it a token that says, you go act on my behalf. And I'm trusting you to do the things that are right. But models don't have a concept of discretion. And the biggest killer in that is that there are a million ways that it can ingest text where someone else can create a context in which it now has the ability to operate, and they are making decisions about the discretion of the model instead of me, right? That's the problem. And the real killer is, so as somebody who spends a lot of time thinking about MCP servers, because the company that I work for, that's one of the big products that they develop is an MCP server. It's a way for other people's LLMs to interact with resources that we own. The killer with that is that I don't have any control over their LLM, right? Like, I don't have the ability to like see whether or not it's making a good decision. I don't have a way to put a filter in front of the text that it's ingesting. I don't have any control over that actual model. All of that happens in the client side. So the best thing that I can do is try and figure out whether or not it looks like this is abnormal behavior from this particular user or from this particular type of request or whatever. But I can't actually do anything to prevent that model from making bad decisions, even though some user has given it authorization to do things inside of my ecosystem, right? That's problematic. And the real killer here is that this concept of prompt injection, now indirect prompt injection, becomes an even bigger problem. Because in the context of a single application, if you have an LLM that stood up inside of your castle, right inside your own little sandbox, it might ingest something that it wasn't supposed to and that has a prompt injection in it and do something, but you have ways that you can interact with that. You have ways that you can put controls around what it's going to ingest. You have ways that you can go through all of the content that you store to look for things that might look like prompt injections. But in an MCP server, or I'm sorry, in an MCP client, an arbitrary user can install any number of MCP servers. So somebody could put a prompt injection in GitHub, and that could get ingested, and then that prompt injection could be used in a completely other application because that LLM has access to all of these other tools, right? That's the fundamental problem, is the controls have to exist in the client. There's no way for MCP server providers to really meaningfully stop many of these attacks. And the killer is that most of the folks who are interacting with them don't have a ton of expertise in what the tools are doing. That's why they're using it, right? They're using it because it allows them to interact with stuff that they wouldn't otherwise be able to interact with. So they don't necessarily have the same concepts of when they should or should not give it permissions to do things. They don't necessarily think, hey, if I connect 55 tools and maybe 20 of them aren't really useful all the time, it only takes one prompt injection coming from one place one time to then hijack any of those tools that are authorized. So I think we find ourselves in the same place that we found ourselves with web applications when Web 2.0 became a thing, right? When JavaScript started getting run in the browser, there was all kinds of ways that people figured out how to break that application that was now running in the client and use that to abuse users. And the way that we fixed it was not by fixing web applications. It was by fixing browsers, right? It was by making it harder for browsers to do those inappropriate things. And I think that that's the place that we should be pointed as we look at MCP. It has exploded, and it's faster than any technology I've ever seen. I remember oh man, so aging myself, I don't know if the grades are super obvious, but like I remember when Docker first started to be used in industry. And Docker had already been around for like 5 or 6 years before it started to get widely adopted. And there was another 4 or 5 years of rollout where people were starting to incorporate it into their data centers. So we had a long time to figure out how it was broken and to build systems around it. MCP was invented last November, right? And there are thousands and thousands of companies that are using this as a core piece of their technology stack. And from a security perspective, we have not figured out how to fix it yet, right? It's all still very raw. So I think that's the hope, is that we figure out ways that we can get better security baked into the client so that users have the ability to exercise discretion. The problem is that it has to happen in the client. Like there's very little that we can do outside of the context of the client.
It just seems like here we are again, with security as such an afterthought, and now we've got all of this stuff in place, and it's going to be this catch-up game of a series of unfortunate events of organizations having who knows, untold damage and data leaks and whatever else. This is this technology is showing up, and part of it, I'm sure, is because of the hype and the push to say, hey, you can now go through the McDonald's drive-through and your order can be AI powered. And
I think particularly for MCP is that it unlocks skills for people that they didn't even know were available to them, and they don't necessarily know how bad the thing that they're making is, but they're making something. And that is a really powerful and useful thing that we don't necessarily want to throw away. A really great example of this, right, is like, I have a coworker who is really, really, really solid, like security engineer, but not a great software engineer. Has wonderful ideas, and he will sit down with MCP and he will crank out code that is great proofs of concept. It's terrible code. It's awful code. But like it's a proof of concept. He had an idea and he didn't have any way to enact that idea so that a software engineer could actually go and build it. Now he does. He has the ability to, in a weekend, build a prototype for something that, it's janky, and it's not safe, and it's not optimized, but it demonstrates the concept.
Yeah, right.
And I think that is the promise of MCP. There's a whole bunch of people who don't necessarily have technical skills that this will allow them to build things in concept. But I think the thing that we have to be careful about is the recognition that the thing that they build, though it might work in the cases that they think of, there are a million. Security is about understanding the difference between how it is intended to be used and how it can be used, right? Like that space in between those two things, that's where security lives. And MCP makes that space much bigger, right? There's a big difference between how it can be used and how it's intended to be used. And so I think as we have to be cautious to not block the technology and say that it's terrible, because it does open a whole bunch of doors for a whole bunch of people to do things that they couldn't do before. But we also have to recognize that, we just gave like the whole world a bunch of table saws. And right? Yeah. And we need to figure out how to get everybody up to speed, or like make the table saws a lot safer.
Well, and I will say, I'm using I use the LLMs to help with code generation. It does seem like you can get into this nasty cycle of spending more time fixing bugs and correcting logical mistakes. We haven't really talked reverse engineering much on this episode, and that's fine, because we're still talking things that are very much related and tangential, and you end up using them in a lot of the same ways. You have a tool that can generate some disassembly or some pseudo C, and you feed it to a model, and it can be incredibly helpful at times, and it can be incredibly unhelpful at times. And so it's like all of the same problems that we were talking about, so far in my experience, pertain to that same, the same purpose, the same application of using them for reverse engineering. And I suspect, when I'm using it, it's at its most effective when it's augmenting my work. It's not replacing my work.
Well,
so it still feels like it's the same.
the way that I tend to use the models from so like I don't use them for a lot of RE, but I do use them for a lot of statistics and stuff, as you might imagine. Like the statistical modeling is a big part of my life and has been for a long time, and I use it in that context a lot. But like I said, I don't use it to write code. I actually very intentionally have an LLM sitting in a separate window. I have a web like a web view open over here, and I have my Jupyter notebook in an entirely separate thing without AI turned on in it, because I find that the code that it generates is crunchy and I can write that code faster. But what I do use it for is to ideate. I will give it toy examples of a problem I'm trying to solve, and then have it spit back ideas on how to solve that using the specific technology that I'm interacting with. And sometimes it has good ideas and sometimes it has bad ideas. But when it's a bad idea, I can just move on to the next one, or I can give it feedback. I can say, well, I don't think that'll work because XYZ. And then it'll spit out another idea. It's like, oh, that's interesting. Why did you use this method? And it'll explain something about that method. And then I can take that conversation and then go and implement the thing much faster than I would have been able to if I was just going out and reading documentation, and much faster than if I asked it to do it and then fixed all the bugs, right? So I think, but that's also because that's one of my core skills, right? I was a software engineer for a long time, and I've done data analysis for like 20 years. So like that's one of my core skills. So for me, I think of it as a superpowered rubber duck. Right? It's something to bounce ideas off of and get feedback in the areas where I am already hyper capable. In the places where I'm not so capable, then I might use it in the place to do the things I'm not good at. And then again, augment my own capabilities, add my intelligence into it. But yeah, for highly skilled folks, I think that the right way to use them is not to do the work. It's to talk about the work so that you can do it faster.
You're right, Kevin. And that really gets to the crux of how statistical modeling works. I get that response a lot. You're right. And that really gets to the core of how the AI voice or the LLM voice, talking about that. It's always
because it wants to agree. It'll always want to agree.
Well, Kevin, I think definitely we'll have to do another episode.
For sure. Yeah.
So thank you again for your time, for joining, and I really appreciate it. I will give you any last thoughts, comments, suggestions, and then we'll wrap it up.
Learn about attention functions. There we go. We'll give the listeners an exercise for the reader. Learn about attention functions. That's where all of the interesting security around LLMs lives, is attention functions.
Attention functions. Okay. All right. So there you have it. Go learn about attention functions. Okay. I think that's a wrap then. Thanks, Kevin.
Cool. Awesome.
And that's all for this episode of Behind the Binary. Thanks so much for tuning in. If you enjoyed the show, please consider subscribing and leaving a review. It really helps us to reach new listeners. Until then, stay curious and keep exploring.